Hello, my name is Kingsley Linus. Welcome to today's mathematics lesson. In this lesson, we'll be having the second part of the topic, highest common factor, HCF. By the end of this lesson, you should be able to identify the difference between LCM and HCF. And you should be able to solve problems on quantitative aptitude involving LCM and HCF.
Just say aptitude.
Aptitude. Before this lesson, I expect that you must have gone through the lesson on HCF Part 1 and also the lesson on LCM. Now, just a quick reminder, LCM stands for lowest common multiple. It can also be least common multiple. Now, the important word there is multiple. What is a multiple? A multiple is a number that can be divided by another number a certain number of times without a remainder. So simply put, LCM is the smallest positive number that is a multiple of two or more numbers. Of course, L stands for lowest, C stands for common, and M stands for multiple. Now, if you recall, from our lesson on LCM, we learned several methods of finding LCM. One of those methods is by factorization. Now, just to refresh your mind, let's see how we use the factor method to find LCM. The number 15 has the factors 3 and 5. 24 has prime factors 2 multiplied by 2 multiplied by 2 multiplied by 3. 42 also has these factors 2, 3, and 7. Now, this example here says find the LCM of the following. Of course, we are using the factor method. So we have 30 and 45, 24, 30 and 36. So we arrange the numbers we have in a table like this. We have 30 and 45. We start with the smallest prime factor, which is 2. 2 into 30 gives us 15. And 2 into 45 gives us 45. Of course, 2 cannot go into 45. Now, we try the number 3. You realize that 15 cannot be divided by 2. And neither can 45 be divided by 2. So we try the next number 3. 3 into 15 gives us 5. And 3 into 45 gives us 15. Now, you realize that 3 cannot go into 5, but it can still go into our 15. So we still go with 3 until we exhaust it. Now, 3 into 5, we bring down our 5 because it cannot go. And then 3 into 15 gives us 5. Now we have 5 and 5. So we can go ahead using the number 5. So 5 into 5 gives us 1. And into 5 we have 1. So at this point we can list out all the factors we have. We have 2 multiplied by 3 multiplied by 3 multiplied by 5. And when we multiply all this, we have 90. So our LCM here, our lowest common multiple between 30 and 45 is the number 90. Now moving on to a second example where we have three numbers, 24, 30, and 36. As usual, we start with the smallest number, 2. 2 into 24 gives us 12. 2 into 30 gives us 15. And 2 into 36 gives us 18. You realize that 2 can still go into some of the numbers. So we go again with 2. 2 into 12 gives us 6. 2 into 15 cannot go. So we have our 15. We bring down our 15. And 2 into 18 gives us 9. Now, the number 2 can still be used. So we have 2 into 6, we have 3. Now, from the look of things, 2 cannot go into 15, and neither can it go into 9. So we bring down our 15 and 9. Now, the next possible number that can go into all three numbers is the number 3. So we have 3 into 3. That gives us 1. 3 into 15 gives us 5. And 3 into 9 gives us 3. We can still use the number 3. 3 into 1, we just bring down our 1. 3 into 5, we bring down our 5. And 3 into 3 gives us 1. Next, we use the number 5. 5 into 1, we just bring down the 1. 5 into 5, we have 1. And then 1, we have just 1. So, we list out all our factors. We have 2 multiplied by 2, multiplied by 2, multiplied by 3, multiplied by 3, multiplied by 5. And when we multiply all of this, we have 360. So the LCM between the numbers 24, 30, and 36 is 360. I'm sure that reminder was worth it. Now let's move on in this lesson. I believe you can recall what we learned in the part 1 of this lesson. HCF simply stands for highest common factor. And how do we practically find out highest common factor? We do that by listing the common factors we have between numbers, and then we take the highest of them all. Now, let's see how this is done. The numbers 12 and 16, for example, we have their factors listed out. 1, 2, 3, 4, 6, and 12. That is for 12. And then we have the factors of 16 listed. 1, 2, 4, 8, and 16. Now you can see that the numbers 1, 2, 4 appear on both lists. So 1, 2, and 4 are our common factors. And the highest or the biggest or the largest of them is the number 4. So 4 is the HCF between the numbers 12 and 16. I believe that reminder was good enough. Now let's go on in this lesson to see one of the important objectives of the lesson. The difference between LCM and HCF. When we talk about the difference between LCM and HCF, we simply mean subtract HCF from LCM. Let's look at an example. We are expected to find the difference between two numbers, 12 and 16. But before we do that, we must first find their LCM and then their HCF before we go ahead to find the difference. Now, to find the LCM of 12 and 16, we use the factor method in finding the LCM here. Now, you can see the number 12, and here are the factors of 12. We have 2 multiplied by 2 multiplied by 3. These are the factors of the number 12. For the number 16, we have the factors listed. We have 2 multiplied by 2 multiplied by 2 multiplied by 2. Now, going by this method, if you recall, to have our LCM, we must take each factor in their highest power available. What do I mean? The factor 2 has its highest power as 4. So rather than take or consider this 2, we'll take this 4. So we have 2 multiplied by 2 multiplied by 2 multiplied by 2. And for 3, we have just 1 3 as a factor appearing among our lists. So we just take the 1 3. And when we multiply all this together, it gives us our LCM 48. So our LCM for 12 and 16 is given as 48. Now moving on to find the HCF, we can as well use the factor method. We have the factors of 12, and yet again, the factors of 16 are listed. Now, in the situation of highest common factor, You can see 2 has been highlighted and 2 has been highlighted. So our HCF is 2 multiplied by 2, and that gives us 4. Now, having successfully found the HCF of the numbers 12 and 16, as well as the LCM of the number 12 and 16, we can go ahead to find the difference between the HCF and the LCM. But at this point, it is important to note that whenever you have a problem like this, finding the difference between HCF and LCM, the LCM will always be bigger than the HCF. Very important. Now, our HCF, as we found here, is 4, and our LCM is 48. When we take the difference, that is, when we subtract 4 from 48, it gives us 44. So the difference between the HCF and the LCM of 12 and 16 is 44. Now, alternatively, we can use a method we call the loop method in finding the difference between the HCF and the LCM of given numbers. Now, how does the loop method work? Observe that here we have a loop that contains all the factors of 12. That is 2 multiplied by 2 multiplied by 3. And we have another loop containing all the factors of 16 here. That is 2 multiplied by 2 multiplied by 2 multiplied by 2. That gives us 16. Now, there's something common between both loops. We have 2 appearing twice in both loops, and that is why another loop was formed inside these 2 loops. Now, the loop method combines the numbers we are expected to find the difference between them. You realize that this loop, what we have in this loop and what we have in this loop are the same. So we lap the 2 loops. One loop can now represent both loops. And then on the bigger loop, we just list the remaining factors that is not contained in the combined loop. I believe that was clear enough. After doing that, the next thing is to find what our LCM is. We can find our LCM from here by multiplying all we have in all the loops combined. What do I mean? Here we have 3 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. When we multiply all this, it will give us 48. And 48 is our LCM. Now, when we take the loop, the overlapping loop at the middle, and multiply what we have in there, we have 2 multiplied by 2. That gives us 4. And 4 here is our HCF. So, we can now go ahead to find the difference between the HCF and the LCM. 48 minus 4 gives us 44. And this is how we use the loop method to find the difference between the LCM and HCF of given numbers. Still on the difference between LCM and HCF, we can use the repeated division method to find both the LCM and HCF as shown here. We have the numbers 24 and 36. To start with, finding the LCM of the numbers 24 and 36, we can start doing our repeated division. First, we start with the number 2. 2 into 24 gives us 12. 2 into 36 gives us 18. The number 2 can still go into 12 and 18. So 2 into 12 gives us 6. And 2 into 18 gives us 9. Now, the next number that can go into both numbers we have is the number 3. 3 into 6 gives us 2. And 3 into 9 gives us 3. We'll stop at this point. And then our LCM can be gotten by taking all our factors to the point where we don't have any uniform factor that can go into both numbers. And then we take our last prime numbers available. So if we take all this and list them out and multiply them, that gives us our LCM. We have 2 multiplied by 2 multiplied by 3 on this line. And then we have 2 multiplied by 3 on this line. When we multiply all this, it gives us 72. Now, using the same method to find the HCF, 2 into 24 gives us 12. 2 into 36 gives us 18. 2 into 12 gives us 6. And 2 into 18 gives us 9. 3 into 6 gives us 2. And 3 into 9 gives us 3. Now, our HCF here can be gotten by only taking the factors, the common factors. So, we list our common factors, 2 multiplied by 2 multiplied by 3. And when we multiply all this, it gives us 12. So, our HCF is 12 and our LCM is 72. Don't forget that your LCM would always be bigger than the HCF. So the LCM comes in front and then we subtract the HCF from the LCM. Now 72 minus 12 gives us 60. So the difference between the LCM and the HCF of the numbers 24 and 36 is 60. Now, having shown you these 2 methods, I believe you won't find it difficult finding the difference between the LCM and HCF of given numbers. At this point, I have an exercise for you. Do well to pause the video and try out this exercise. I believe that you must have found out that the LCM between the numbers 48 and 72 is 144. And the HCF is 24. And when you take the difference, that is when you subtract 24 from 144, it gives you 120. So the answer to this question, if you solved correctly, is 120. And for number 2, the LCM is 72 and the HCF is 12. When you take their difference, you would have 60. If these were your answers, you are correct. Now, to the second objective of this lesson, solving quantitative aptitude problems that has to do with the difference between the LCM and HCF of numbers. Let's look at some examples. Now, if you observe this carefully, you should be able to realize that all we have here are factors of the number 9. And what we have in this loop are factors of the number 15. Now, our LCM is gotten by multiplying all we have in the loops. That is 3 multiplied by 3, that is 9, multiplied by 5, that gives us 45. So our LCM here is 45. Now, our HCF here is what we have in the overlapping loop. And we just have only a number there, 3. So we subtract 3 from 45. And when we do that, we'll have 42. And that's how we got our results here. Now to the second sample, following the method we just had in the first sample, we multiply all we have here to get our LCM, and that gives us 90. And our HCF is to multiply what we have here, 2 multiplied by 3, that gives us 6. 90 minus 6 gives us 84. And that's how we got this result. Now, in the third loop, the content of this loop are missing. How do we find the contents? The number 72 is expressed as prime factors here. So we must find out all the factors that we need to list here. Now we can simply do that by writing out the number 72 and we divide by our prime factor 2. 2 into 72 gives us 36. 2 into 36 gives us 18. 2 into 18 gives us 9. And 3 into 9 gives us 3. 3 into 3 gives us 1. You realize that 3 has been listed here already. So the contents of this place should be all of this. That is 2, 2, 2, and 3. Now, for this loop, we have 75. The number 75 cannot be divided by 2, but it can be divided by 3. So we start with 3. When 3 goes into 75, it gives us 25. And 3 can no longer go into 25. So we try the number 5. 5 into 25 gives us 5. And 5 into 5 gives us 1. So apart from 3 that has been listed here, we have 5 and 5 as the content of this loop. Now, having done that, it means we must find out what our LCM is and then subtract it from our HCF. When we multiply everything we have here, we would have the LCM as 600. And when we subtract our HCF, 3, that will give us 597. That is what we should have in this box. For our last sample, we have 2 missing numbers. That is the value of this loop. How do we do that? We do that by simply multiplying all we have within the loop. And when we do that, we would have 108. Now, to find the difference between our LCM and HCF, as usual, we multiply all we have here. When we do that, we would have 216 as our LCM, and our HCF is 36. When we subtract 36 from 216, we have 180. So our answer here is 180. I believe that explanation on the samples were clear enough. Now, I have some questions for you to try. Pause the video and try these questions. I believe you are done. If you have solved these questions correctly, for question 1, your correct answer should be 414. Now for question 2, your missing figures for the overlapped loops are 2 and 5. Now, if you've also solved correctly, your answer should be 13,850 as the difference between the LCM and the HCF of the numbers. For question 3, the missing figures are 5, 2, and 2. And the answer, if you solve correctly, is 1,330. Having gotten to this point in this lesson, let's take a quick summary on all we've learned so far. First, we learned that the acronym LCM means lowest common multiple. Secondly, we learned that LCM is the smallest positive number that is a multiple of 2 or more numbers. Going further, we learned that HCF means highest common factor. We also learned that HCF is the largest out of all the common factors. Also, we learned that finding the difference between HCF and LCM means subtracting HCF from LCM. And lastly, we learned that the use of loops is a good way to find the difference between HCF and LCM. Don't be in a hurry to go. I have 2 questions to test how well you understood today's lesson. Question 1 says, express 56 as a product of prime factors. Option A, 2 multiplied by 2 multiplied by 2 multiplied by 7. Option B, 2 multiplied by 2 multiplied by 3 multiplied by 7. Option C, 2 multiplied by 3 multiplied by 2 multiplied by 7. And lastly, option D, 2 multiplied by 2 multiplied by 2 multiplied by 5. The correct answer to this question is option A. Lastly, question 2 says, find the unknown value. Option A, 17,616. Option B, 16,766. Option C, 76,167. And option D, 17,568. The correct answer is option D. Here is where we draw the curtains for today's lesson. I believe your time was worth it. See you in another mathematics lesson. Bye-bye.